Okay, now that we have an iterator, let's implement some more methods. The first one we're going to implement is toString. Before we do that, I'm going to go and, as usual, create some tests for that. So public void test empty toString. So our empty stack is going to have a toString method that we want to return bracket, close bracket, colon 3. I believe the capacity on our empty stack is 3. I can actually check that right now. There it is, stack empty 3. That's the capacity. And we want the toString method. Okay. So while we're here, we'll also implement, or we'll also test the ABC string. Okay. And for the ABC string, what we want is bracket A, comma, space B, comma, space C. Those commas and those spaces are very important when you're dealing with two strings, when you're dealing with string matching, and they have to be exact. So if you don't have the right spacing, then your strings are not going to match. Okay, and we get the toString method for that. And now we've got our test cases, and you can see that if we actually run this right now, our tests fail, but it's interesting, our tests fail because of what it returns. We expected ABC colon 6, for example, but what we got was BddStack.listStack at this number here. And what that is that's the default method for toString. You get the class name essentially at the hash code. That is certainly not what we want. So we're going to have to override that implementation. So let's go ahead and implement our toString method. We'll go to list stack. And we'll go up to source and we will generate some code here. And you see we get some choices here. One of them is toString. That's one possibility, overrides another. Let's choose the toString method just to see what that does. Okay, so the toString method is going to use our representation. It's going to use the contents instance variable and the capacity instance variable in order to automatically generate a string. So let's hit generate just to see what this gives us. Okay, so that's interesting. It gives us the class name and it says contents, which is the name of the variable, equals contents, capacity equals capacity. Now this is not a good toString method because it actually reveals the name of our private variables here. We made them private for a reason. So we're not going to ultimately use this, but let's see what it generates. Let's go ahead and save this and then rerun our tests. Okay, the test failed as we expected. But take a look at the tests. We're expecting ABC colon 6 as a list, and we're getting list stack contents, and we're getting that A comma space B comma space C that we want. Excuse me, and then we're getting the capacity equals 6. So actually that's pretty darn close. And I'm thinking if we start with contents, and then instead of saying capacity here, just put a colon, and then getting rid of this last curly brace, let's see. I'll bet if that's not it, it's pretty close. And look at that. That passed our test, doing something simple like that. Okay, fantastic. Okay, so this is a perfectly fine implementation, but what I want you to understand is that this is a primary method. It has access to the concrete representation. It uses the private instance variables contents and capacity. Question, can we implement toString without using the representation? And the answer to that question is yes. And we're going to do that now. And in order to check our implementation, we're first going to have to comment this out. And of course, when we comment this out, everything breaks again because we're using the default object implementation of toString. And to make sure that we do not have access to contents and capacity, that we do not have access to any particular representation, we're going to go to abstract class and we're going to implement it here. I'm going to insert some code here, generate code. I'm going to override the methods. Actually, I'm going to override equals hashcode and toString because I want to eventually implement all of those as secondary methods. But we're just going to worry about toString right now. Okay, so how can I possibly implement toString without access to any concrete fields? Well, the answer is I may not have access to a particular representation, but I do still have access to all the methods in stack because look here, abstract stack implements stack. So it knows about all those methods in stack and I can legitimately use them. So it knows not only about push, pop, depth, and capacity, but because stack itself extends the interface iterable, it also knows about the method iterator, from which we can get an iterator and use for each loops. So let's take advantage of that. And the more or less common way of implementing a toString method is to start out with a string builder. And a builder is a design pattern, SB equals new string builder. And it's commonly used to, when you're constructing a complex object, and then you're going to return that object. And sometimes the construction process is involved, and a string builder and a builder in general can help you do that construction process more efficiently. But even if you aren't worried about efficiency, it's a fairly simple pattern, and I tend to use it all the time. So I create a string builder, SB equals new string builder, and the last thing I want to do is return the string. Okay, and essentially in between those two things, I just append things to the string builder. So the first thing I want to append is I want to append that left opening bracket, and then I'm going to append some elements, and the last thing I want to append is, well, after I append those elements, I want to append a closing bracket. I might as well put the colon in there too, and then I'm just going to append the capacity, which I just can call because I have a capacity method in my interface. And now in between here is where I want to append the elements. Okay. I actually am pretty sure this is not going to work, but I want to try a for each loop first. So for each element in the current stack, and the current stack is this. All right. So I can iterate over the current stack. SB append element. Okay, and anytime you have this append, it's going to look at that and say this needs to be a string, so it's going to call the toString method on that. So append the element, and then I want to append a comma and a space, because we've got to be very concerned that it exactly matches the string. So let's see what this gets me when I run the test. Okay, I still failed the test, so let's see what's happening. It says I expected ABC:6, but found ABC comma space :6. It's a little confusing here, especially when you have brackets in your string representation. These brackets here are from these two brackets right next to each other are from the JUnit test. It's saying I found this, and there's nothing in between those two brackets after the letter C. Or I was expecting that, and I found this. I found a comma and a space after the C. So basically, I'm putting this comma and space after everything. The problem is, I thought I could use a for each loop, an enhanced for loop, but I can't. I have to actually create the iterator here. So I need a has next here. I need another has next check. And it won't let me do that inside of a for each loop. So I'm going to say iterator equals this dot. Actually, I'm not going to do that. It's asking me what an iterator is. I'm just going to import it. And now I'm going to say this, and it automatically gives me iterator. And now I'm going to use the standard iterator paradigm. I'm going to say while iterator has next. Okay, I'm going to say SB append. So this is going to be very similar. SB append iterator dot next. Okay, and then SB, and then I'm going to say if iterator has next, then and only then do I want to append that comma and a space. Okay, so we don't need this enhanced for loop anymore. And that should bring us something that's close. And in fact, it's exact, and that works. So we've implemented the toString method without relying on a particular implementation. What that means is no matter how many different implementations we write, we will always have a toString method that gives us the correct string for a bounded stack.